Okay, so this is an inhibitor GCPR or GI. So normally how an inhibitor GCPR works is with an inhibitor ligand will go into the receptor, which will send a signal down here. Now down here is where GTP and GDP switch out, so GTP will switch into the place of GDP, which will activate the alpha subunit to go into adenylate cyclase, turning it off because it's an inhibitor GCPR. Now, adenylate cyclase is responsible for turning ATP into CAMP or CAMP. So that's the normal process. Inhibitor ligand will come here into the receptor, which will switch out GDP and GTP, sending the alpha subunit here, which will turn off adenylate cyclase, turning this off. So no more ATP is turning into CAMP. So now when a human is infected with Bordetella pertussis, the bacteria responsible for whooping cough, something will happen to this entire function here. So Bordetella pertussis produces this thing called pertussis toxin, or PTX, and pertussis toxin affects this down here, this trade-off between GDP and GTP. So now that this can't happen, now that GDP and GTP can't trade off, the alpha subunit is basically stuck here. It no longer gets its energy to move over. So the alpha subunit can no longer move into the active site of adenylate cyclase, which basically means it can't turn off ATP turning into CAMP. Now this is bad because too much CAMP inhibits the immune system and I guess that's basically why you get that cough, and then that's also why your airways become inflamed, which causes the whooping sound when that whooping cough gets its name from. So basically that's how that works. PTX will affect the trade-off between GDP and GTP, which makes it so that the alpha subunit can no longer switch into adenylate cyclase, no longer being able to turn it off, which means there's going to be too much CAMP. It's not going to stop being produced. So yeah, that's basically how that works. Too much AMP is not good for the immune system. Okay, so that's essentially it. Thank you for watching the video. Hopefully I explained it well. Bye.